Swayam Prabha. Digital India. Educated India.
First, a little bit of discussion on morphology, then go to conditional random field and the chunking problem. Also, a discussion on the next assignment and the mode of evaluation on the assignment. So, in the last class, we made some remarks about the morphological processing and the morphological phenomena for the language. And we took this analogy of dressing for different occasions. The word also dresses itself, that means gets morphologically transformed depending on different situations. A very representative and educative example is conjugation of verbs, how verbs dress themselves up in different situations, controlled by mainly 6 parameters, 6 influencing factors: gender, number, person, tense, aspect, modality. So this particular point I would like to dwell for some time on. The reason is that it is very instructive to see how verbs get transformed. Now, we took the example of jana and its future tense form and understood that if I follow the path from root to the leaf, I will get the form of the root word transformed according to gender, number, person, tense, aspect, modality. So this example was shown. Now let me elaborate this a bit more. We are entering morphological processes and the combinatorial concerns involved in this. There are these 6 factors. Gender can take 3 values: masculine, feminine, and neuter. But neuter is absent in Hindi, so 2 values for gender. The attribute number takes 2 values, singular and plural. In Sanskrit, it takes 3 values because there is a number called dual, and this we see in Sanskrit and a few other ancient languages. So singular, dual, and plural. Person are 3: first person, second person, third person. Tense can take 3 values: past, present, and future. Aspect can take 3 values: progressive, perfect, and default. Modality can take at least 4 values, but there are languages where it can take more. So declarative, imperative, interrogative, and exclamation. So we record these attributes and the number of values they can take. And then we see that there is a combinatorial explosion possibility. So if I take the GNP TAM combination, then with the number of possibilities recorded in the last slide, I have 3 gender, 2 number, 3 person, 3 aspect, 3 modality, 3 tense, 3 aspect, and 4 modality. Sorry, I'll just repeat this: 3 genders, 2 numbers, 3 persons, 3 tenses, 3 aspects, and 4 modalities. Multiplication gives me 648 as the product. So given a verb root, also called the stem, we can theoretically have 648 forms. Okay, so now let me see how this can operate. So if I take jana to go, then for masculine gender, G equal to M, number as plural, person as 3, tense as past, aspect as progressive, modality as default, I see ja rahe the is the form that results from jana with these values of gender, number, person, tense, aspect, modality. So they were going, ja rahe the. This is the this is the form I get from the root by operating uh, operating according to these 6 factors. Okay, so now this way, if I follow the path from the root to the leaf, I can potentially have uh, 648 into number of verbs forms. So there are some more combinatorial considerations. It has been empirically observed across languages that typically about 30% of the lexical repository of any language is verbs. So that means 30% of the words in a language, the dictionary words in a language, are verbs typically. So if I assume the lexicon size to be 1 lakh, 100,000, then there are 30,000 verbs. And if unambiguous morphology existed, that means for GNP TAM value, you have unique leaves, then we could have had 30,000 verbs into 648 forms. So that's about 20 million forms or 2 crore verb forms. Okay, can you see that? So 30,000 verbs giving rise to 2 crore verb forms. So this itself is a yeah.
What exactly was the lexicon size? Could you again tell?
If we assume about 100,000 words in a language, English I think has around that number of unique words. Okay.
Oh, okay.
So, okay. Typically, so 30,000 words. So we could have 20 million or 2 crore word forms. So this itself would be a combinatorially large possibility. So we can do some reflections on the morphology combinatorics. So there could be a blow up of about 650 times. Okay, 30,000 verbs multiplied by 650. So only verb forms occurring by themselves could give rise to a 20 million words corpora. So if I just record all the verb forms and put them as my corpus, okay, the text corpus, then just by doing these verb forms, I can have a 20 million words corpus, which is a delightful situation for any NLP researcher. Okay, 20 million words corpus is not something you see every day. But this combinatorial blow up, this doesn't happen. Combinatorial blow up from the point of view of combinatorics, but a happy situation for NLP researcher. So this kind of multiplicity of textual form really doesn't happen. Why? We need to understand two phenomena going on here. The first phenomenon is called syncretism. Okay, a very, very important consideration in understanding of morphology of languages. Syncretism. This means overloading of forms. And English is a language where syncretism is of high degree. Okay, and when syncretism is high, uncertainty is also high. That means by looking at the word form, can you identify the influencing factors? So if you look at will go in English, we have understood this before. I cannot be sure of the gender. Is it male or female? Because in English, the verb form doesn't change with gender. In Hindi, it changes. Jata hu, jati hu. But English, it doesn't change. So gender is uncertain by looking at the verb form. Number is also uncertain. Is it singular or plural? We will go, I will go. That is also uncertain. Person again is uncertain. I will go, you will go, he will go. By looking at will go, you are not sure about the person. But by looking at the form, you are sure about the tense. Will go is future. So I'm sure about the future because of the auxiliary verb, which is coming before the main verb, will. And I'm sure about the default aspect. If it was progressive or continuous, it would be will be going. That will be a continuity of activity. And the modality is declarative. I will go. Will you go? That would be a change of modality. That will become interrogative. Oh, I will go. Then that will be exclamatory. You will go positively. That is a command. So that's an imperative sentence. Okay, so by looking at the phrase will go, I do not know about gender, number, person, but I know about the tense aspect and modality. But this will not be the case for Hindi. If I look at jaunga, I have the complete information. So for English, the uncertainty is higher because of lower morphology, and therefore the entropy of the language, okay, a technical term, entropy of the language. The entropy of the language, that kind of activity was conducted long time back in 1960s, 70s, where Professor Shannon, okay, Shannon's theorem you may be aware of, undertook this task of finding out the uncertainty of English language. Okay, and this was the question was cast in the form of uncertainty of forms and probability values associated with those different forms. So as far as morphology is concerned, English is poor or loose compared to Hindi. Hindi is poorer compared to Marathi, Tamil, Hungarian, and so on. So now I think you have understood that the morphological regularity and the morphological richness, okay, corresponds to this particular picture, this particular situation. Here I am showing you the path from jana to ja rahe the. Can somebody verify that this is the picture you are seeing? Jana to ja rahe the.
Yes, sir.
Yes, sir.
Right. Yes, sir. Okay. Okay. So the richer a language in terms of morphology, for gender, number, person, tense, aspect, modality, the path will lead you to a unique form. Okay, unique form. But these forms will coincide. They will become same for different paths if the language is morphologically poorer. Okay, so that's an important point, and we say when the same leaf form appears for different paths, we are witnessing the phenomenon of syncretism. It is called syncretism, which means overloading. That means for the influencing factors, you have the same word form, and you can immediately see that this is the first source of ambiguity in written text. First source of ambiguity in the written text. In the spoken text, the first source of ambiguity is word boundaries. Okay. In written text, the first source of ambiguity is morphological ambiguity. The same form for different influencing factors. Okay. So there are these interesting combinatorial questions, and the more we study morphology, and the more we are careful about the influencing factors of morphology, the better is our foundational level processing in NLP. Okay, if you have a very strong morphology analyzer, then the words are broken into its parts very correctly. Quickly will be broken into quick and ly, not quickle and y. No, okay, that will not happen. It will be broken into its parts. The suffixes and affixes will be separated very cleanly, and these features of number, tense, gender, etc. will be able to extract from the word form itself. Okay, and this is a very important stage in natural language processing. We need to know a little bit more about the morphological process, and we discussed free morpheme, bound morpheme. In bound morpheme, we discussed prefix, suffix, infix. So those were done. Now we would like to distinguish between two different kinds of morphology, again very fundamental to natural language processing: derivational morphology and inflectional morphology. So the derivational morphology typically changes the part of speech. Okay, and also it can combine different morphemes together, or different free morphemes together to form compounds. For example, hairdresser, hair and dresser, these are two different words, but hairdresser is what is called a multi-word. So these are also called compound nouns, and compounding is a derivational morphological process. In English, these are written separately with a space between them. Modern languages do this, but more ancient languages, they do a process called compounding or sandhi. Okay, they do sandhi and samas. So hairdresser would be joined together. Many times in English also we depict compounds by a hyphen between them. Okay, so dry dinner, for example, underground is joined, but dry dinner is not joined. Okay, and different parts of speech also can combine. But a more basic form of derivational morphology is through affixing. So read goes to readable. Read is verb, readable is adjective. Eat is verb, eatable is adjective. Break, breakable, perishable. Similarly, read could have become reader, okay, where the noun has the verb is given rise to a noun. So from verb you can have adjective readable. From verb you can have noun reader. So it depends on the affix that is attached to the stem to produce the word. And here the part of speech typically changes. Typically the part of speech changes, but this is not a necessary condition. Okay, in derivation morphology you also have situations where the semantics changes but not the part of speech. Okay, I would like to leave it to you as an exercise to show that derivational morphology doesn't always change the part of speech. Okay, so in derivational morphology, phonological changes happens, read becomes reader, category changes, read becomes reader from verb to noun, and there can be a semantic change, the meaning. Read is an activity, reader is a person who is doing the reading. Okay, so when we do derivational morphology, these are the changes which happen. And sometimes an interesting thing also happens. It introduces new meanings. For example, reader is somebody who is reading, but reader has another meaning of a position in the university. Reader is equivalent to assistant professor. Reader can also mean the reading head of a mechanism, the reader of the stylus, for example, the reader of the printer maybe. So its semantic change happens, and new meanings also can be introduced. An interesting phenomenon is called back formation. So sometimes we think by looking at a longer word that it has been created out of a smaller word, but it is not always the case. Resurrection, for example, is a new formation. Not a new formation, sorry. Resurrection existed before. From that, English created the smaller word resurrect. Preemption existed before. Preempt came later. Television existed before. Televise came later. Donation existed before. Donate came later. Okay, so this is called back formation. Normally, we are used to a morphological process which increases the length of the word. Okay, boy becomes boys. It increases the length. So normally in morphological processes, length increases, but in back formation, which is another morphological process, the length decreases, just like preemption becomes preempt. Again, an exercise for you. Look for back formation examples in your own language, in your mother tongue. Do you have back formation in your own language? Okay, and then the other kind of morphological process is inflectional morphology. This is called inflectional suffix insertion. And normally the inflectional processes are plurality, number changing, and tense changing. Okay, so noun inflectional suffixes are plural markers like s, possessive marker like apostrophe s. Verb inflectional suffixes are third person present singular marker s, past tense marker ed, progressive marker ing, past participle marker n or ed. Adjective inflectional suffixes are er, so fast, faster, fastest. So these are inflectional morphology. So you might have immediately understood that inflectional morphology is characterized by the fact that it normally doesn't change the part of speech. Okay, so read reads, read reads, same verb form only. For it has not changed the part of speech. But reader, verb has become noun. Okay. In inflectional morphology, the part of speech normally doesn't change. But exercise for you: look for examples where the part of speech can change and still it is inflectional morphology. Look for such examples. So you have got 3 exercises. 1. Look for examples in your own mother tongue to see if derivational morphology always changes part of speech. It may not. Okay. Does inflectional morphology always preserve part of speech? It may not. And look for back formation in your own language. Okay. So these will then cement your understanding of morphological processes. Okay, so there can be false analysis in morphological processes. Productivity is high typically in the morphological processes. Reader, walker, speaker. Okay, ER is a very, very productive process. False analysis. So you may break the word wrongly and may end up with a stem which doesn't belong to the language. So, for example, for the transitive verb read, if you attach able to it, it becomes readable, and it is a valid word of the language, readable. But gameable is not a valid word of English language. Okay, though people might loosely use the word. So able doesn't get attached to everything. Okay, and we have already seen the false steps in case of lily, for example. You cannot break it up into li and li because li is not a valid word of the language. Okay, but you can have exceptions also. Saleable, marriageable, reasonable. These are valid words of the language. False analysis. So hospitable, sizable. These are okay, but they cannot take the suffix et. You have hospitality, but not hospitability. You do not have sizability. Okay, these are not allowed. So the point I'm trying to make through these examples is that sometimes you may overgeneralize. You may think that et can be added to any adjective. Okay, any adjective, and then you can create a noun out of it. But that is not the case. The morphological analysis has to be careful about such false operations. So similarly, bound-based morphemes, that means the morphemes which cannot stand on their own, which are not free, their analysis can also lead to false conclusions. Okay. Now I have been holding this off for some time. Some of these classic works and modern developments I should mention. One of the classic work is MDL, minimum description length. Are people looking at this slide, MDL, Morphesar MDL? Can somebody verify?
Yes, sir.
MDL, okay. Yeah. So there is a very celebrated paper by John Goldsmith, Unsupervised Learning of Morphology of Natural Language. This actually ushered in machine learning approach to morphological analysis. So it is a must read for any student of natural language processing. I'll request the TA team to give this reference on all the 3 platforms. John Goldsmith, Unsupervised Learning of Morphology of Natural Language. And this is also a very celebrated work, Cruz and Lagos, Unsupervised Discovery of Morphemes, okay, which came immediately after, and based on the principle of minimum description length principle. That is a very interesting principle based on, also called Occam razor, It's a very interesting principle. Okay, and the intuition is very clean. Let me tell you the intuition. So suppose I have boys, ladies, toys, girls, balls, and so on. Now, how should I break the word? Boys, should it be broken as BO and YS, or BOYS, or BOY and S? How should I break it? Now, minimum description length principle says that you can break the words into their parts. There are many ways of breaking them, but that breakage which gives minimum length to the dictionary and the affix list is the best possible breaking of the words into its parts. Okay, so this is the minimum description length principle. The size of the dictionary and the size of the affix list combinedly should be minimum in length. Okay, so this is the best possible hypothesis for the morphemes that you are dealing with. So what is given to you is a list of word forms, and you are asked to create a morphology analyzer in an unsupervised manner. So you keep on breaking the words into its parts. So the objective function, which is maximized, or the loss function, which is minimized, is such that the dictionary size is of minimum length. Okay, so this is the MDL principle, minimum description length principle, and based on that, a very well-known morphology analyzer has been created. It is called Morphessor. Okay, this is a universal morphology analyzer applicable to all languages based on minimum description length principle. So Morphessor you can download and use it as a tool. Now another classic work which was motivated by information retrieval. Morphessor was motivated by NLP. Okay, Porter's stemmer is another classic work. This was motivated by information retrieval. Now information retrieval people are not interested in morphemes which are valid in the language. They are not interested in. They are interested in a canonical form of the word, a canonical part of the word, which can be used for indexing the document. Okay, so it doesn't matter whether boys is broken up into BO and YS or BOY and S, as long as the part gives me a pointer to a document which is relevant for my query. Okay, so information retrieval people therefore would not care for valid parts of the words, okay, approved by language. So that's why this Porter's stemmer was created, and it has a set of very elegant rules. Porter's stemmer was created for English, and long back, about 15 years back, we tried creating Porter's stemmer for Indian languages. Okay, but that effort was not successful. That is another story. I would like to tell this to you some other day. Why for Indian languages a Porter's stemmer like approach did not work. So Porter's stemmer uses rules like the following. If a word ends in EMENT, then you convert this suffix into null, and what remains is a proper root of the language. So EMENT. For example, replacement, you remove EMENT and you get REPLAC, and if one E was added to it, it would become a valid word of English language. It would be replace, but no, you get REPLAC and EMENT, and that's a very productive process. You can have replacement broken up into replace and EMENT. Okay, and there will be more examples. For example, placement. Okay, placement, replacement, hutment, HUT and MENT. This is not EMENT, it will be MENT. Now Porter, very cleverly discerns that what remains after EMENT must have a weightage, must have a minimum length. For example, you cannot break cement. If you remove EMENT from cement, what will remain is C. C is not a valid morpheme or word of English language. It's a character. So the first syllable must have a weight. M is an indicator of that particular measure. So M should be greater than 1. So what you are seeing on the screen is Porter's stemmer, important for information retrieval. But suffix stripping here involves a constraint. That constraint is that the previous part should have a particular length. Okay. Recent developments, a very celebrated development is fast text, an embedding that respects multilinguality and morphology. So it came from Facebook, and fast text is widely used because the embedding respects morphological or subwording, breaking the word into its parts and getting those embeddings. But we have to say more about this point. and you have embeddings for 294 languages. So multilinguality is also a very important matter there. Then the pre-trained embeddings for Indian languages, we tried to create embeddings for Indian languages. It was reported this year also, work by Kumar Saurabh, Kumar Saunak and Diptesh. And this tried to show that if we generate embeddings from Indian language corpora, we can use them for important Indian language NLP tasks. Okay. An important concern there was, can we do morphology analysis purely based on embeddings? We don't have to use any morphological rules. We don't have to train any machine, but purely by geometric distance between morphological stem and morphological form, we could do morphology analysis. That was the question, but it was not completely successful. Again, a story to be told some other day. And we took major languages from Indo-Aryan and Dravidian family. Then joint model for embedding and morphology. This is a new development and interesting intuition. People are looking at joint model for embedding and morphology. Can somebody verify? Some student, please. Embedding.
Yes, sir.
Okay, great. So a joint model for word embedding and word morphology. This is in the first workshop on representation learning in 2016. Now, this joint model, the word joint model, you will encounter many times in AI, machine learning, NLP, of course. In NLP, we want to do part-of-speech tagging and named entity recognition together, okay, jointly. We want to do named entity recognition and semantic role labeling together, okay, because these tasks are such that they help each other, okay. So part-of-speech tagging and morphology jointly, because they help each other. So typically two layers of the text which are adjacent to each other, which are one below the other or one above the other, they can typically be jointly done, okay, to the mutual benefit of both. So so this was word embedding and word morphology jointly being done, and here morphological analysis and embedding of the subwords are jointly created. Okay, interesting piece of work. I thought of mentioning this to the class because joint modeling is important in NLP. Byte pair encoding is indeed a very important development, came again from speech, like many ideas which came from speech to NLP, like noisy channel, for example. So this paper by Senrich et al. Is highly cited and used heavily. Neural machine translation of rare words with subword units. So they were the ones to first apply byte pairs for doing machine translation. And I gave you the example of jaunga, khaunga, where if unga has been translated, then it can be reused, even if the training data doesn't contain khelunga, okay, or girunga, for example. So the unga suffix is very helpful. So that is the motivation for subword. And what byte pair encoding does is that it progressively marges, this is called marge operation, two consecutive characters into a single character. So of course, the two consecutive characters should cross a particular threshold in terms of frequency. So this is my corpus. Here I see that AD appears 3 times, AD, AD, AD in the first, second and fourth string. Then I marge it and give it a symbol P1. And after I have done this, I find that EE is the next frequent character string which can be marged. So this gives rise to P2. And then I find that this new marge, P1 and D, has become frequent now. So P1 and D is marged together to give rise to P3. So this is, you can immediately see a kind of data compression situation. And from this data compression, I reduce the corpus size. I capture the most frequent substrings, okay, a ranked list of most frequent substrings, and add them to my dictionary, okay. And if I do my NLP well for these frequently occurring substrings, then I expect the result for the larger NLP task also to be good, okay. So this is the byte pair encoding example, and it is inspired by compression theory, and it also uses minimum description length principle. The BP construction is very simple, as I illustrated. It is an iterative process. We count character pairs and keep on merging. The merged entities also are candidates for further merging. Okay, and the merging always happens in pairs. So this the BPE construction has been found to be very useful for, especially for deep neural network based natural language processing. So these are the modern developments, and I think you should remember the two classic developments, which are Morphesser and Porter-Stemmer, based on minimum description length principle. And the paper by Goldsmith is a must read because it showed how to use unsupervised learning for morphology. And BP applications are understanding the suffixes, capturing the suffixes, and reusing them in the testing situations. But one should be careful of the pitfalls. Li, homely, homily, ugly. Their li should not be stripped off. Okay, so now I would like to spend next 5 minutes, let's say, after which we'll do question answering. On chunking, the mathematics, algorithmics and mathematics of chunking, I wanted to discuss in detail, and we'll do this next week, algorithmics and mathematics of chunking. So again, the noisy channel metaphor, and this is not a new situation for you. You have encountered this in part-of-speech tagging. The same knowledge can be reused. So input is a string of words, output is a string of labels. In our case, the output is a string of chunk labels, and there are only two labels, B and I. So Mansane Unnacha Prayatna Kela, part of speech tagging has been done, and we get B, 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 I. So there are 3 chunks here, 2 of single word, and the last chunk is of 2 words. So it is a much simpler task, which you have remarked before. And the first level of chunking is only B and I. After that, we give the type of chunk. Is it a noun chunk, verb chunk, preposition chunk? Now, the decoding or the mathematics is as follows. We have to do an argmax computation on the probability of Y given X, the probability of output given the input. Now, the modeling here is to be noted. The modeling is in terms of an exponential distribution, okay? Not in terms of multinomial distribution, which allows me to compute the probability by means of ratios. Not so. Here, the modeling is in terms of exponential distribution, and the exponent is a special construction. It is constructed out of the product of the weight vector and the feature vector. Okay, so you get the features of each position. So you can look upon each position as a target for labeling, and at each position I have a word which is my observation. The parts of the words are my features, the properties of the words are my features, and the environment, syntactic environment around that position gives me more features. The part of speech tag of the previous word, part of speech tag of the next word. These are very obvious, okay, very obvious features which need to be used in support vector machine or any feature based computation of labels. Now CRF, conditional random field, is a sequence labeling algorithm for NLP. Okay, originally it was used heavily for computer vision and was very successful. Then it was adapted to natural language processing. Okay, so by the way, the same story applies to deep learning also. Deep learning was found to be very successful in image processing, computer vision, speech recognition, anything to do with signals. Okay, the moment you come to larger conceptual chunks, conceptual entities, words, phrases, sentences, then that success is not as spectacular as when you use it for signal level tasks. Vision, image processing, speech are good examples of that. For text, you have to apply special machinery. Sometimes you have to use rules, hybrid systems, classical machine learning also. Okay, so here you can see that the modeling of probability is in terms of features. Okay, and when the decoding happens, when a new sentence comes, I simply have to compute this probability efficiently. Okay, and you have to use this, otherwise you encounter data sparsity. The whole sentence will never very unlikely to appear in the corpus. Okay, so you have to break the sentence into small parts. This is our trick for handling data sparsity. Whenever a big entity appears, I break it into small parts and do my processing on that. This is a method of handling data sparsity, and there is a name for this. The name for this is back-off smoothing. Back-off smoothing. That means I cannot get the whole entity labeled. I break it and then label it. Okay. So the whole argmax computation has underneath it the situation of data sparsity. So probability of y given x, the probability of the chunk levels given x, is modeled as an exponential distribution. The exponent is the dot product of the weight vector and the feature vector. That means which feature must get how much of importance. So for example, shun, T-I-O-N, which is a feature of the word, should get very high weightage because it clearly distinguishes the noun from the rest of the words. And noun often begins a chunk. Okay, so it must be given a lot of importance. Now this is learned from the training data. The weightages are learned. Remember that these lambda values are learned from the data. But before that, let's understand how decoding happens. We will begin question answering very soon. We begin with the hat symbol, and from hat I can go to B or I, begin chunk or inside chunk. From B I can go to again B or I can go to B or I, and this way at every level I can have two nodes as the children, and therefore 2 to the power the number of words in the sentence is an exponentiation possibility. But we need not do so. We can advance only those paths ending in the same level and kill off other paths which have no chance of producing the best possible path in future. The same Viterbi idea. Okay, so now the only question remaining is that what are these arc probability values which control my path length probability, partial path probability computation. How do I get those probabilities? Okay, hat to B, B to B, B to I. These probabilities come from the mathematical formulation here. The probability will be a function of the weight vector and the feature vector. Okay, so here the sentence is brown foxes jumped over the fence. What will be the chunk? Brown foxes will be B and I. Brown foxes is one chunk. Jumped will be one chunk, one word chunk. Over is one word chunk. The fence will be a 2-word chunk. Okay, so B and I's will be placed this way based on the already learned probability from the training data. And how do you learn those probabilities from the training data? You cannot take ratios now. Okay, that is not how the probability is modeled. You will have to compute the lambda probabilities, the weight probabilities, and that you do by something called gradient descent, either by SGD, stochastic gradient descent, or LBGF algorithm. So these are the two algorithms we have to discuss when we discuss the training of conditional random field. But the overall idea I think we have got because we have already encountered these ideas in part of speech tagging. So one method of computing the best path is through Viterbi decoding. Another is by beam search. Okay, another is by beam search. So beam search is something we have to do, and beam search is a kind of A star search. Therefore, A star search also we have to do. So gradient descent, A star search, beam search, Viterbi is already done. Those are the algorithmic topics we need to deal with going forward. Okay. So in beam search, what will happen is that I will start with the start node. I will bring the children on what is called the open list, and then send the hat node to the closed list. Then choose one of the B or I to expand. So as I go on doing it, my candidate nodes for expansion goes on increasing. So I say that my open list goes on increasing in length. Now I put a stop to the open list growth anymore. So I have a beam length. I control the length growth in the open list. I cut it off. Okay, and keep doing beam search and then again go to and go on reducing nodes from the open list, and then when I reach the threshold again, I apply the beam width once more. This is a way of controlling the A star search in terms of its efficiency. Okay, so either beam search or Viterbi is done on the search path for decoding. So how to get those probabilities is our next concern. This is the training algorithm for conditional random field. So let me stop here. So your next assignment will be on chunking. The input will be sentences. The output will be chunk levels, only B and I. So if the input is many birds were flying, you will have two chunks, BI, BI. The goal of this assignment is to find out whether pause tagging indeed helps. So you will do chunking with pause tagging and without pause tagging. Okay, chunk directly the words, no pause tagging. Do you see any difference in the accuracy? This is the goal of the assignment, and in this case I have requested the TA team to give you chunked corpus. Okay, the training data will be given to you. Okay, chunked corpus, so we'll talk about that. And I am also deciding that your assignment evaluation will be in a different form. What we'll do is that every 2 weeks, all the groups will discuss with the TA team, and I will be present for some of them, your progress. Okay, so we'll measure your progress every 2 weeks and give a mark based on the progress. Okay, so there is no deadline for submission of the assignments. I will keep on giving assignments, and you will keep on working on them. Okay, you will keep on working on them. Every 2 weeks, we'll see how much progress you have made. And it can be anything. The progress can be huge, 100%, or it can be 50%, 60%, depending on your load, situation, etc. But in the end, we will add all these marks together, okay, and then use it for your grading. So this is a form of continuous evaluation. Every 2 weeks, the project and assignment groups, or every 2 weeks the groups will meet the TA team, and I will attend some of them, okay, to assess your progress. So every 2 weeks, and assignments will keep coming continuously. Okay, assignments will follow the theory closely. We are doing chunking now, so therefore this assignment to chunking. Okay, so more about this will come in the announcement for more clarity. So now I can take question answers.
So last time Saurabh Garg asked, the word post can also be seen as a free morpheme, right?
Yes. So postponement, for example, post positioning, post mortem, post editing. So post is a very popular prefix.
Rishi Agrawal asked, is little y different from capital Y in chunking maths?
Little y different from capital Y. Oh no, in chunking, since you are making use of features, capitalization is a very important feature. Okay, so you have to retain capital letter, small letter.
Oh no, I think he's referring to some formula in your slide where small y, capital Y are present in some mathematical.
I see. Okay, we'll take it up in the next lecture. Huh?
Sure. Saurabh Garg asked,
so just a minute, Diptesh. Capital Y typically means the whole string, and small y means an element of it typically, but I'll clarify this further.
Right, sir. Should I go to the next question?
Yeah.
So Saurabh Garg asked, is lambda a vector in the chunking mathematical equations? If yes, what's the meaning of e to the power lambda?
E to the power lambda, so that is the modeling part. E to the power lambda into f. Lambda into f is the dot product of two vectors, and that is raised to the power of e. The whole thing is also divided by a normalizing factor to make it a probability.
Right. And the last question from the previous session is by Kaveri. So can we say lambda is the learning parameter here?
No. Lambda is not the learning parameter. The learning parameter will come in gradient descent. Okay, this lambda is the weights of the feature vectors. Learning parameter is never learned. Okay, it controls the speed of learning. But here lambda is learned from the data.
So from this session, the first question by Rishi is "Ja rahe the" is not unique for person, right? It seemed the slide is indicating uniqueness.
Oh, no, no, no. That was not my intent. My intent was to show the transformation. हम जा रहे थे, आप लोग जा रहे थे. Yeah, it is not, the uncertainty of the person is not resolved there. Yeah, Hindi also has syncretism, yes.
So Drumel asks, what do we mean by exited earlier in case of back formation? We still use the word donation, question mark.
So typically we think that the longer word form came after the shorter word form. So go became going, go becomes going. So first go came in the dictionary and then going came. Okay, that is typically the process. So forward formation is this, go to going. Now suppose going existed before and go came later. So that's called back formation. So preemption existed right from the beginning. Preempt is a relatively newer word.
Right. Drumel also asks, what is the core definition of inflection morphology? I understood the example, but to find other inflections, what do we look for? And in brackets, he also writes, I thought it was about preserving the pause, but that clearly is not the case.
No, no, no. Preserving pause is an important point in inflectional morphology. Typically, inflectional morphology preserves the pause. Okay, so inflectional morphology is guided by factors like tense, gender, number, person, and these kind of features. And in derivational morphology, we change the meaning typically, and the part of speech also. Okay, so read to reader, there is a meaning change. In inflectional morphology, I think more definite point is that it doesn't change the meaning. Okay, of course, this is subject to debate. You might say that boys has a different meaning because we are talking about multiple boys. So there is a bit of a gray area there. Inflectional morphology typically doesn't change part of speech. Derivational morphology changes, but there are exceptions in corner cases.
Fair. Vishal asks, sir, do we have to perform stemming as data pre-processing in our assignment?
You will have to if you are taking the word parts. Okay, if you're taking the word parts as features, then you will have to do stemming. You will have to do stemming, yes.
Sure. And Saurav Garga asks, something like containment will not be separated by ement rule. Why not we relax the rule to ment, which seems more natural as a suffix?
Yes. So in Porter's stemma, we had both ement and ment. Okay. So please read up the paper by Porter where he gives all these regular expressions conditioned by weight of the syllables.
So, Akshay Bhattaja asks, any example for bound bases in Hindi?
Bound morphemes, yeah. Bound morphemes are morphemes which do not have independent existence. They have to be attached to other words. Unga, for example. You will not see a sentence where unga is sitting separately.
Rishi asks, Viterbi idea can be applied only if Markov assumption holds, right? It is not clear if chunking makes Markov assumption.
Chunking makes Markov assumption. That's why it is conditional random field.
Yeah.
Yeah. So it is the Markov independence assumption is called click. Okay, click assumption. So I have to spend a little more time on this. Yes.
So what do the B and I tag means? I think it was clarified in the lecture.
So B means begin the chunk.
Begin.
I means inside the chunk.
Inside the chunk. Yeah. Anubhav asks, sir, could you explain the mathematical probability portion for CRF? I did not understand the feature vector and lambda concept.
Next class, huh? I'll do that.
Fair. Ritwan Goswami asks, can we still assume the Markov assumption for chunking? Yes, it is assumed. Moving on to Parth's question, how are the chunking
one
done?
One second. Sure. So in conditional random field, the independence assumption comes from neighborhood. Okay, so typically the level at a position ideally depends on everything else in all the positions. But in conditional random field, the immediate neighborhood is important. The conditioning is based on the influence of the immediate neighbor. So that's where the click assumption comes. And this Markov assumption is based on something called blanket. Okay, there is a blanket which supplies the conditioning part. More about this as we develop the theory.
Parth asked, how are the chunking done? What rules are we following precisely to make a chunk?
Not rules really. We are going from state to state and computing probabilities, and in the end, one of the leaves will give me the chunk.
So
Yeah.
I mean, like what rules for to make the ground truth? Like the
You mean the
how are
gold
we
standard?
deciding what I mean, yeah, what's the standard to make a chunk in a sense?
Oh, acha, no. So I think you are referring to how you create the annotated data. Is that so? Hello?
Sorry, sir, I missed you. Could you repeat?
I'm saying that, are you saying how do you create the training data?
Yeah, yes,
Huh.
sir. Yes, sir.
Yeah. So annotators sit down and give these BI tags. So they do it based on their understanding of what is a chunk. Now, chunk is not as complex as part of speech tagging. You intuitively know what should be inside the chunk and what should not be. So the blue sky, for example, the annotator will produce BII. So it is done by human beings based on their understanding of the language.
Yash asked, how do we choose between discriminative training and generative training for a task? So either CRF or HMM, what should be the choice?
Yes. So discriminative training can accommodate features. Let us reserve this question for next week.
Right. And the final question in today's session is by Kartavya. And he asks, sir, besides assignments, what else would we be including in the grading?
The project will play a role, and one examination. I think mid-sem and sem are compulsory. I'll have to find out from the institute. But this continuous evaluation of assignment, project, and examinations with reduced weightage. Okay. And I typically used to also have seminars in the courses, but seminars may be difficult this time. But maybe each group can do a 15-minute seminar on a paper that will ask them to read. So these things will form the grading methodology.
Right, I think those were all the questions, sir.
Okay, so let me end by requesting all of you to ask as many questions as you can on the chat box. Okay, please keep asking questions.